To be able to actually visualize your target protein, you need to do a little bit of theoretical work, which will help to facilitate the binding between the antibody and the target protein. So here is the checklist. Biochemical properties of your proteins, protein you aim to detect, isoelectric point, its solubility. Is it a membrane protein, or is it what is its expression level? That's very important. Is it low expressed protein or very abundant? Where is it localized, in which organ, which tissue? These are the crucial informations. And also cellular localization can be of importance, especially if protein to be detected is of low abundance. And you may say, well, but how do I know how much of my target protein is in a tissue? There are actually databases. My favorite is the PAX, where you can check on a histogram, you can check estimated amount of target protein in a tissue. It is not, of course, for all species in plant science, but for main model species, you will obtain this information. And as a rule of thumb, if a protein is abundant in less than 10 ppm in a given tissue, we are hesitating to make an antibody, because it means, especially if a protein has a cellular localization in cytoplasm, it may be difficult to detect it. Not impossible, but it may be difficult. And there's also ePlant from University of Toronto, which covers quite many model species and which gives us expression level on mRNA level. Of course, mRNA may not completely translate to a protein, but it will give you anyhow an idea of also in which organ you will find the most of your target protein. Sometimes you may need to analyze senescent leaves, sometimes a very root tip. I mean, this is very important when planning your Western blot. Which tissue are you going to process?